fine ka. Good evening. So ngasigi class hours si aduna kino ni kuin ngarang torambadu work energy power ni ka work energy power kaya ugre do tower si just a second silere ka aduna kuin question number kaya hodi to ugre ngarang gida I would question number 45 hodi to ugre male ka nate 45 tinate koi Sigi 46 taugré, question number 47, 48 photogram male 48 ka. So no 49, 50, 51, 52 sidi dum ngamudra. Yengak tabra. Wait, so okay, fine. So question number 40 question number 48 taugré na ka. Question number 49 dai ji no the potential energy of a long string when stretched by 2 centimeters U. If the string is stretched by 8 centimeters, the potential energy stored in it is, and I have a call. It's a very simple question, but no need to say hadi to do ni do no ngamani higher gadi muka move on to do ni ka. So no yaradra yarodra haina ro ngamadra ngamoidra haro
yarni sir
yarni buka. Okay, fine. Question number 50, 51, 52 yengo. Nina luba yawram question number 50 is a mass of 0.5 kg moving with the speed of this on a horizontal smooth surface collides with a nearly weightless spring of force constant this. The maximum compression of the spring would be haba. Adu ibatar gadi smooth haven in a friction do late in a lower knee. Aduga nasagi kinetic energy of this mass half mb square half layer mass na 0.5 layer v square na 1.5 square layer ni ka so 2.25 layer ni adu into to with half mb square do kay gamana ni have the half kx square gamana ni half layer k na 50 layer adu x square do the my compression do ni ka aduga you have to solve x ka adu do ani do equator ga ka haziki do kay to obra gyan ta obra lo ni mak Sir na hojikta hai do question number 50 ki sir na hojikta hai do gyan ta obra
Hoy sir
okay Lakshmi katang ko may kay gino
Sir, have you
Prithviras asigi je question number 50 ki sir na je spring ama layer me spring ji da mass amna kay do ba collide to re ba so sorry yes spring ji da mass na collide to re da masagi mass gi magi Kedoba magi kenolei ba kinetic energy am lei jai ko half mb square natra so my kinetic energy si has a potential energy of the spring the convert to gido ne ba spring je compressed orga and the potential energy stored in the spring the half k kaino kx square ne ba half kx square so half mb square is equal to half kx square half of ka cro m ga v ga di pirame k su pirame and kai putokadoino compression the small x to x putokadoine ba ka compression x to Kyan tabra?
Oh, tani sir.
Yare ka adoin to puto adum answer tani. Nuine still ngamoy har gadi sa dum toge ka kem kai di. Then question number 15 the has no when a long string is stretched by 2 centimeter its potential energy is u. If the string is stretched by 10 centimeter the potential energy stored in it will be and I have a ka. So CCD kaino have da 2 centimeter ni na 2 square or ni 10 centimeter or gadi half kx square na 10 square la ni so 100 by 4 d 25 so answer is d ta ni ko 25 u gyan ta hobra ji kida ngawra kanam ko magtre question number 51 gi sigi 25 u ta ni ji gyan ta dabra hello
tare sir
tai bu ka okay fine so aduni 25 u have the half the potential energy formula ji kaino half k x square neva x to aham baisina 2 my centimeter or meter or millimeter or kilometer or doesn't matter 2 centimeter ko 2 nen lo kai ni same amazina 10 centimeter ne the half k x square ne half su constant ni k su same spring ni na constant ni 2 square duna aham baiduna half k 2 square d 4 amazina half k 10 square d 100 adu gadi 4 by 100 is 1 upon 25 neba. Aduna ahamba dugi 25 times or neba ko. So 25 u or neba. Then question number 52, there's two springs A and B have spring constants Ka and Kb such that Ka is 2 times of Kb. Ka na yam tini helekan ba the double times kal le ko Kb dagi are stretched by applying force of equal magnitude. If energy stored in spring A is Ea, then energy stored in B will be have a cost. So question number 52 is sir tawzira natraga noi ngamgadra hairo. Tawzira di to kaiba tawse ba ko? Okay, fine. Tawse ka. Tars. Okay, fine. So CC can only go. Can board it. All right. So CC yam live question ni board saying right. Can to ki bon clean tor. Hey may go kitang swong yo ma boards. Anyway. Isa si oyo ina lo kinang tori pam da ka. Kitang no ite. All right. So CC the higher zika no have da Ka ka. Ka is equal to 2 times of Kb. I remember when ka. Now stretched by applying force of equal magnitude. Force chap money have a cost. If energy stored in spring A is Ea have a cost. So Ea is equal Ea is half Ka Xa square. And Eb na kayo half Kb Xb square. Then Eb Ea by EB to kayo so it's a very simple question. Now for si chap mani haven in a queen kadoni hamatamda F A is equal to FB in a pyramid. Hamatamda if in a stretched by applying force of equal magnitude haven in a force and do money in harameva force and do manavena Ka X Sersi am somebody I sum kenotodrum samdra ne tareka auna nina kidowi hamatamda k the onthokseba ko xa by xbz kaido onsige hamatamda kb by k the onthokseba ko auna nina sida e b by ea haijira is equal to haraga kitang samake ko noi ngawre tamune ko eb by ea si makha asi kakre ko so kb by ka lerba step amadi dum hapki kb by k now xb by xa is kay lakani hamatamda xb by xa is xb by xa xb di xb na mathak lakaduni na ka na mathak lani and kb na silani duga cc was whole square lane cc ko aduna lower sida half kakre ko aduragadi kay lani have the ultimately kakra matungda ka lani and kb di kay tai hai K is 2 times of Kb tai hai ka. So step toge amatanga hapki ke and 2 times of Kb by Kb the Kb ka kre ka. Therefore kay have ai Eb is equal to 2 times of Ea. Then 2 times of Ea is the right answer ka. So gyan tabra si se ma'am. Ka. Okay, fine. So, yare. Aduti maka proceed si yam live question ni ka. So, noi handaki test ki sir na habido noi akoi si around 2 days mukti mang re class to rudre 2 days ka. So, do chang nai na to no to si aduka sigi handaki keduwa today is Friday ka. Saturday Sunday. Friday and Saturday 2 days later ka. So, sigi sida question ma'am si loi na so to godo ni ka. Ako'y kitang litap kre 2 days mangudagi do kaimta kaide adum ngam na tawgodini. Now question sige 52 votor springy lore now various forms of energy, the law of conservation of energy hare. So yeng asi ka question ji kai yauge na ka. So question number 53 hadi 2009. Now sige mamangda hangba question 2009 gi matungda hangba question noi de yauragadi sardum thazalo ko so adum solve tauge aduga yaudragana yaudre ko. So question number 53 is kaino a body of mass 1 kg is thrown upwards with a velocity 20 meter per second. It momentarily comes to rest after attaining a height of 18 meter. How much energy is lost due to air friction? Now, a body of mass 1 kg is thrown upwards with a velocity 20 meter per second. Aduragadi mana kabam thopa magi height amadi layramni buka. It momentarily comes to rest after attaining a height of 18 meter. Adudi mazi 18 meter karaga mazi amuk tarakadune buka. But asing badi mazi air friction layram da bata 18 nation ki hen gadam ne question jina hangning is. How much energy is lost due to air friction haragati? You can just kedoba maki kedoba potential energy ani duda noina puthosu yare difference loss yare ko nadragana kaigumba kaidi magi height se 20 meter per second the langkhatpa matam da let's say kaya haisiga 22 meters kagada baneba aduda mazi kai khatang kareba 18 khatang kareba audi 18 khatang kage hargadi velocity kya da langkhattuino haibdo aduduna atugi kinetic energy duga nasaigi half m 20 square haita half into 1 into 20 square minus half into 1 into harga kano square hani ko adudi kano dudi khangje adududi puthokadoine bako adwain tro hot kadene. So sir na haji gyan tabra natraga sir so tawuna phabra kumnaro solve tawsira yadra kaiba
yarni sir.
Yani Lakshmi gidi yani have ko anai kenato ba atai gaidi
Yani sir.
yani Prithviras yani hare thawambadi
Sir, Yadav Mali.
Yadav male ko. Okay, so yani hare ko. All right, okay, fine. So chetasu kume yani na ko. All right, so next key question number 54. 300 joules of work is done in sliding a 2 kg block up an inclined plane of height 10 meter. Work done against friction is have ko. So CC ding gatra question number 54 se
Ngamni sir.
Okay, fine. So ngamoy do mi yarg di sir dum solve to biyo na dum haro ko. Not a big deal. Adum solve to godo ni. Adi mi amana ngamni hire ga su no ngamoy do amatang yaw bada mi lo ngamni ha amatang yaw do tawze have dum taw do ni ko. So question number 54C adum kasham lu banate kamay taw do no 300 joules of work is done in sliding a 2 kg block up an inclined plane of height 10 meter. Adu regadi magi kaido ba magi z okay inclined plane 10 meter. Okay, fine. So work done against friction is an have neighbor. Now, magi theta di piram de ko. So anyway, today sida work done piram me mass piram me adagi kedoba inclined plane adugi hisiki height to piram me adur gadi work done against friction putho u an have neighbor ko. So si nui solve to wangam gadran esen ki oh you cannot yauge how let me admit it. So question number 54 have the 2006 key question Z lonimangam gadra kum the video yang kuin kum the video gunu ba recorded session ne ba ko tab the nungai roi ba. So CC tawzira yadra
Tawse sir.
tawze ba ko. Okay, fine. Tawzi ko do there. All right. Okay. So let's see how to tackle this question. Okay. 300 okay the what joules of work is done in sliding a 2 kg block up an inclined plane of height 10 meter ne ko. This is the fracta is the angle of inclination jima piram de ba kan ko. Inclined plane hai ko. Aduga magi height se inclined plane gi height si kaido ba magi si 10 meter ne ko. It is 10 meter hai. Anyway, not a big deal. So this is 10 meter. All right. Fine. Now see angle theta is pyram agadi kanu ai gadam pyram. Anyway, fine. So see the lay block am lay ko. sigi block si aina mathakta pukhale si yongna bai tare ka aduga aduda tawba work done si kedoba 300 joules ne ka. Okay, fine. So work done against friction is an hand. Anyway, masi marak the soil layering kalasi adur gati masi kedoba magi weight na ka. Let's draw the free body diagram. MZ layani adur gati magi som saita MZ posita smailani ka. And then pot si aina kedo we have the mathakta pukhalibini na som saita layani MA ka force MA is som layani. How the friction do the kadom the line friction zu som site layani hatareka on a friction ji kai the yexige the masagi kai sida to make chalajira si mg cositaje si sida kedawani have the plus kedawa f kedawa fk hatareka fk kai no di masi motion the laibani fs low we are the static friction low we are the kinetic friction low gudam ne ba. So magi see the normal reaction have the normal reaction the upward ni ka. So see the mz sin theta have a term ni ka. So work done against friction ka. Work done against friction dang have ne mo hansi ka. 300 joules of work is done in sliding at 2 kg. Now adu ibita argati akoina sigi see the ka kai have I have the total work done se sidaina si po kakat pada labor total work done si kaino have the 300 joules of work is done in sliding at 2 kg blah blah ka. So akoina kai can be have the half mu square have lay ka sisina aduga plus have the kai the half m v square is 0 ne ka on a change in kinetic energy do adudu kai ga manani have matam the work done against friction plus work done against gravity ne gyan dai ga ja gyan tabra ta tabra se ngai ko sir na haji taw ba pot se kayumba friction sunglai leram da bata ga di aina mazi aziki block se aina push to khat pamatam da ko mana yogada chang am leire ba friction leibani na adugi chang du di yora roy mazi kitang wat na yora ne ba gyan dai ga ja ana adu mana kedo we have total work done to 300 joules ne high ba ko ana half mu square se cc kai du mo do have the this will be 300 joules and work done against friction do they kang de but work done against gravity di it has reached a height of 10 meter aduna mgh this should be equal to work done against gravity have this is the potential energy increase to on m do kaino m do 2 ni z na 10 ni height na kya no height to 10 ne ba so the work done against friction should be equal to 300 minus 200 which is equal to 100 joules and a ko so minus to the question je now sigi question ji ma checksel law so mind to question ji ma ka so mind solve to den have the free body diagram adu da id solve to ningai yaw de id kai gino di kemta p di hata mo ne ka just mo haji kai na da cc kai do ba again cc sir ko ne cc kai do ba conservation of mechanical energy palira na hangaga di no it is not kai gino kai conservation of mechanical energy na trino have matam da see the friction yauri ko and friction is non conservative force neba ana non conservative force laiba matam da koina mechanical energy is conserve oide ko so adu maina laigaduni aduna sigi simi amno yarba gyan tabra Lakshmi Thongamba Prithviraj
Tani sir.
Taiko. So
Yes,
main
sir.
is CC ne bako. If this is adum half m u square the magi id kedoba. Id potsi kaino hamatam da starting the ko hek horok matam da initial kinetic energy ne lay. Adu moina adu do sir nang sa habdo. Adu kitang oi question ji lale habudi yade but push to kat kiba matam da sibo your lep ki kai higher ga de adu gi mong du da approach storm ni bako. Adu na tabe id dum kaya adum force lay mong hadi kanal sliding je ko do you want it but anyway that's okay so cc yare ko ma'am yare ko
ꯌꯥꯔꯦ ꯁꯥꯔ.
Yeah. Okay.
ꯍꯣꯏ ꯁꯥꯔ.
Okay. So let's proceed to the next question. Great. Yeah. Power your ko. So power gi the first question nina sir solve tawrage. Ado yung 2016 gi matungda hangbagumba yawbre yung question. Now power c si tawdring idana ay kano tawge ko question amtang hana solve haidi power z kaino han haige ko. Power z kaino khangma mi yawbra? Power z kaino? Power
Rate
z
of work done.
yes.
Done by time.
Yes, good call. Work done by time. Yes, rate of doing work or rate of work done has you guy. So work done by time name. Powerize. Now, okay. Hasdik aduna akwina power z p is equal to kaino have the w by t have ya ko. Ado again p is equal to w di kaino f into s by t ne ko. Aduna f into v have yadra kaigino di s by t is equal to v yai ko ana power is equal to f into v ja sisu khangjeloba mayamna khangnai jina power id mayamna habidi ade but noina hana khangnai jina power p equal to w by t but kaidoba exam da di p equal to f into v the best of question sudum anga kani ba ko adugini adana sisu important noi yare ko de ma'am yabra yai ko
Yai sir.
C P equal to F into V. C is C am important whatever. Okay, so see the high no 2016 the hang ko a body of mass 1 kg begins to move under the action of a time dependent force. So force pyramid where I and J are unit vectors along blah blah blah. What power will be developed by the force at the time t and I have a ko. So adu ergadi sigi questions idi knowing gadra mass pyramid force pyramid acceleration putho acceleration dagi kaidoba velocity putho velocity dagi kaidoba force ga into tawsalo aduga phangani ko so cc madi sir tawrage acceleration is equal to harga f vector by m which is equal to adum 2t I cap plus 3t square z cap adum tazarni kaina 1 yen badudi yen da chap manarena ko now acceleration is the kind of the onka db by dt ne ba ko on velocity vector d kind of have the I dum samjal lage ko now na t square nate chumra chumi ko t square by 2 2 ka kreb ko so t square I cap lere plus t cube z cap lere ko since kind of have the v vector is equal to integration of db vector which is equal to integration of yare kaino asi myam se ko into dt hai ta yarbo sidum yani na ko khangani da so adu lere adu gadi power p power is dot product of force and velocity so what is force 2t I cap plus 3t square z cap and dot product log dini kanaga t square I cap plus t cube z cap which is equal to 2t to the power 3 ni ka id 1 the 2 the 3 ni dana 2t cube I cap plus 3 t to the power 5 j cap yaw 2t cube 3t to the power 5 2t cube 3t to the power 5 so option number B is the right answer मैम लोनी में ज्ञान था होगा सी किसे
ताई सर.
Yai sir.
Okay, fine, great. Yeah, so let's proceed. Question number 56, 57, 58 si paro aduga karamba sarna tawzige have the hero ka. Par. Question number 56, 57, 58 par.
Sir,
How?
sir, the question thagin sir the yaudaba.
Okay.
Adu 60 adu sir mamang 60 ga 60 was people get sir.
60 have question number 60 is it?
Hoy sir.
Okay. I the question number 57, 58, 59 the arba.
Yani sir.
Okay, fine. Kings. Remember, CC ka. Question number 60 is what shape ka.
Hoy sir.
Okay. Yeah. What's so atopa question kay kano ni khang da ba yar su ka so mai na dum sir da hang pe ai. Okay, fine. Yare ka. So yengo. Water falls from a height of 60 meter at the rate of 15 kilogram per second to operate a turbine. The losses due to frictional force are 10% of the input energy. How much power is generated by the turbine? So, yengo duragadi kamay solve tawni haba. 60 meter wangba mafam amdagi water ji dum keno torakadini ko flow torakadini aduga magi sidai da kedoba turbine am lerni ko so turbine ji rotate torani hatare ko at the rate of 15 kg per second. So kaino have the moise the p is dm by dt am pyramid dm by dt is 15 kg per second. Sis pyramid ko height am pyramid height is equal to 60 meters. So height pyramid by potential energy pyramid chamani ko mgh. Now the losses due to frictional force are 10% of the input energy. Aduna friction number 10% mange. So how much power is generated by the turbine and have neighbor ko? All right, fine. Now energy 10% mange aduga power cam generate the we turbines in a heaven adudi. Okay, so now what is the total energy higher gadi mgh ka? So total energy say u and higher 0 ka. Total energy say let's say u high 0 p high 0 ka. So that is equal to m mg and kedoba h right there ka. So kedowi mg kano mg 15 kilogram per second ka. So let it be m adum laser so no aduga z 10 ni ka m into 10 into height in 60 ni adu 600 m tare ka. Now power have kaino have the adum du by dt har su ai kaino the change in kedoba energy ne ba. Now sigi sida akoina kaidoni have matamda ngasagi the losses due to frictional force are 10% of the input energy have ne ba. And the power generated by turbine C makti oiraroi ka aduna C langani aduna aina zikidoba 10% oirabanina loss torabanina u dash haitare ko u dash 10% bu mangagadi 0.90 into u haidine ba ko habidi 10% mang ba 0.90 ne ba ko adudum khangjalu auna 0.90 into 600 oiragadi kedoba 90 into 6 ka manaramani ko so 90 into 60 kay ka manare ko see 90 into 6 so 6009654 haitare ko so 540 joules per ni sorry 1 second 540 m have ko in z kamay rin so this is equal to 540 m adu ibitaragadi power di kaino have the d of u dash by dt ni so adu di 540 into dm by dt tare adu aragadi 540 into what is dm by dt dm by dt is 15 adu di 0 sim sum 5420 lere ko adu ergadi noi cd 2 na tawwa haibra 5420 5525 plus 429 30 31 515 678 so 8.1 kilowatt 8.1 kilowatt tare ko so asigi sir na solve tawri style ji gyan ta hobra
Tahu sir.
ta hobe ko kaino ne atai di ta hobra ma'am Lakshmi Prithviraj
Sir, U prime là với tập biểu thầy.
U prime la is kaino habidane moina 10% of kedoba input energy total energy se U neba ko adu 10% mange hadi pot amagi 10% manga gadi always 0.9 hadi for example nangonda let's say you have rupees x layer nang 10% loss oigragadi nangonda kya la ni haragadi 0.90 into x le hauni ba kai na di 10% loss have say can I guys that the 10% loss is equal to kedoba 0.90 into kedoba total height something like that never have the kai have the 10% loss has 10% put on adu dong minus to ni adu the 0.90 taro ito gyan ta dabra
Tay sir.
asisi short adum sisi kangjalo ko shortcut oina 10% gain harga na kai 10% gain organ 1.1 into tawada 10% loss harga 0.90 into tawada adi 10% discount le ren hareba adi for example pot amaji 10% discount le harga di kaino simply 0.90 into tawaba adu gi price to the phang dine ba kayum ba pochi 10% kedoba rate se increase tawgre harga di 1.1 into tawdeba 20% 1.2 na 30% discount harga di 0.7 into tawdeba 0.70 haigera 0.7 haigera yan taita de
Tay sir.
direct Lakshmi ki anta hobra
Taris.
okay fine
Tahu sir.
however okay so let's proceed atopadi noi sidagi gyan tarba atai asi question number 58 question 57 oh ID question am yam mal 57 58 59 si hum sidi noi dum yadra noi gi su sir na haiba sigi like si later ba sunya ya deko noi keno to godam ni you have to use this book ko sida yar question me am solve to godam ni so do getting makha or si makha question number kya no so question number 56 57 58 se loing up madra karam batau ji haro khalla ga haro 56 57 58 khanaro do haro saja haro 56 57 58
Sir, 56 ang tawag mo.
okay 56 am tau zero okay question number 56 in a high the heart of a man pumps 5 liters of blood through the arteries per minute at a pressure of 150 mm of mercury if the density of mercury B blah 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 and G equal to this, then the power is have a co. So do you know kitang kenogi pressure measurement of pressure using mercury column do hapet khang dadi aroi na tragan na pressure at depth nung ama kadum by formula ama khang dadi aroi. So anyway, 5 liters of blood through the arteries per minute at a pressure of all right. The density of mercury pyramid rho pyramid rho z whatever pyramid power put however all right okay fine I dum direct dum put hoge ka okay power is equal to kai di pyramid per minute so volume by time pyramid n kai pyramid pressure is pyramid n kai pyramid rho is pyramid ka sorry sir pressure si di kai dagi rho gh dagi ko rho gh is equal to pressure ita si pyramid ko volume by time pyramid adu ibtar gadi adu ga mun putoi power putwa hai bane ko okay fine yeah adu gadi pressure si dagi koina kai khangba ngam have the force per unit area na tra pressure have za auna f by a neba f by a sida aina kai gumba f by a le ko volume by time ni 2000 batar gadi volume by time in 2000 batar gadi kai tani have the force into velocity tarni ko ona pressure si kai tani have the f by a into volume by time smaina so now f by a di kai no rho gh into volume di kai no volume di moina 5 liters pyramid so 5 liters si queen kai no the on gear gadi 1 liter si kanoni ko 1000 kanoni ko 1 decimeter ni or 10 to the power minus 3 meter cube ne ko so 10 to the power minus 3 meter cube ne ko aduna 5 liter si 5 into 10 to the power minus 3 meter cube or ni ko aduga times ina moina kaya haiba per minute say in 60 seconds harni ka so rho gh rho di kena rho d density ni so 13.6 into 10 to the power 3 kilogram per meter cube everything is perfect kay no di SI unit ta han laita ba ya de ba hotring de ka then amazi 10 lo salani g je 10 lo zo harame height c kay no 150 c kay no mm ni meter don gya ga di 10 to the power minus 3 hapani ka into 5 into 10 to the power minus 3 divided by 60 in my paper. So 10 to the power 3 yung 10 to the power minus 3 yung ka kre. 10 din na si ka di 6 tare. Adu ergadi masigi pot si. Ay to chumi ka rho gh chumi da. Pressurize keno rho gh na force by area na. Okay fine. So sige 6 ina 13 zida ka kumatam da 6 to 12 layer ka the 1 6 layer ba point naman ni aduga amuka 6 to 12 layer ni 40 adu di 6 5 6 6 36 6 adu may di 2.26 mukta ani ka into higher okay 2.26 into 15 into 5 t kano 75 la di kedoba 15460 ka 75 ni mani so into harga 10 to the power c minus 3 ziga sigi kedoba 10 ziga 10 to the power minus 2 tare ka aduna have 10 to the power minus 2 harga di 100 ni yen ne ka so which is equal to 2.26 into 75 by 100 so 25 na ka gadi 25 3 75 25 4 100 so adu di 3 ni yellow 6 3 18 6 3 to 6 7 3 to 6 so 6.78 by 4 adu di 414 27 6 4 24 38 7 no 9 4 36 so 1.69 muktai so 1.70 must be the right answer no check tori ngo 1.70 tabre yung sige
Tai siya, tay.
tayo ka okay fine so adain to gudo niyo ka so gyan lo ta obra
Oi, sir.
so sige mo question ji kitang tricky oi ba no the multi dimensional approach ne ba si se ko no ina just power gi definition dot product of force and velocity adain adu katang da confined to orga leibia da question ne so just take it take to solo aduga siguma question ji hanjan practice to godam ni noina revision la kuma tam da ko siguma question take to solo hairo
Sama high ski below se. 150 mark mm kamaina
Kaino di mo si the Hiramisi mercury gido 150 mm of mercury. Have the pressures a quina mercury gi kaino the low height the comma height of mercury column season erga pressure on biava. Adugi pressure gi formula rho g h o eva. Rho is the density of mercury, g the exertion due to gravity layer, h in the height of the mercury column. Adainto pressure puto piava. Yantai ko tade.
tare
Tare, okay, fine. Yare kaino di. Yo. Atay gyan tadaba mi yoriba. Hero, tadragadi hero. Yanerable inemak.
Yani sir.
Hoi, sir.
Okay, fine. Adudi, let's proceed. So, question number 56 to break. Kalo 57, 58, 59 yung gyan tadaba yawre. Kala hero. Cheta kuma ji aiko. Cheta question number 57, 58, 59 no cheta kuma isu kayam kaide. Library de labor kangbu and then ito ba chak saba kangbu kay kama whatever ko timing jine yada bagi hai. So question number 57 a particle of mass m is driven by a machine that delivers a constant power k watts. If the particle starts from rest, the force on the particle at time t is very simple question. I don't know. Ngam moidor sir hero start toge. Kalo 57, 58, 59.
Tawuse, sir.
Those ever call. Okay. Those. So CG57, so that is a particle of mass m is driven by a machine that delivers a constant power k watts. Power pyramid k ne na ko. P is equal to k watts pyramid. Watts ka is yare da. The mass ne m pyramid the particle starts from rest. The U is equal to 0 pyramid. The force on the particle at time t ka at time t. And the force put however. Force at time t is equal to what? Okay, fine. Now, aina kay khangi have matamda force putu am in acceleration layrani ko, and then power c aina force by force into velocity has I ko na work done. So I can write k is equal to haraga my mass pyramika ma mass into acceleration force into displacement s. So CC kay tare work done tare ka divided by time t. So mine p ka. Start the force on the particle at time t. Force put however. So why should I write that? Okay, anyway, C force put however. F to put however na draw. I do a good D. Yes. So power have the force into displacement. Force into distance to the hierarchical divided by time rate of work done there. And now F is equal to P tar KT by S star. Power constant K is a constant. But again, the problem is S is the option the yaw gave a call. S in a problem or so the S C in a Zugaram to Utare, Kanum to Utare F's car. I have to do something in order to get S. S Lotoga kainam mochin ba atopa na mochin ba variables ka. So kamain to zige yengzi power is constant oi have ko. How the velocity again acceleration put up na tragana SCV square minus ut plus half at square s half at square hayabra. So can I write like this kt by half a t square hay ka yabra ngaubra si se ko adu lere aduga aduduna aina kidoni have the 2kt unati 2k harage ko 2k by harga habdi kenone ba 30 ka 30 square ka kram 2k by harga a ina muka kai habi ya har matamda f by m haibong yare so f by m habi yare and then t amaga layani ko adu iba targa di aina cgc answer taramani ai answer ure noi ubra adu di answer ure to f is equal to root over 2km by t ngawbra 2km by t yaudabra 2km by t ja 2km t to the power minus 1 by 2 chumbra si tare ko 2km to the power t to the power minus 1 by 2 gyan tabro ta dabro myam sigize khara ngawar male myam si gyan tabro ta dabro kaino ka ang kumagti si ba tare ko okay atay kumagti kay gino
Tare, sir.
Sing.
Tare, sir.
sing bro tabra taye noi natraga makeup ama tumura ba sana sun like tayo da so sigi si kaino ni sidagi sila idi kangbra ba sidagi sila idi kangi ko
Khangija.
s is equal to ut plus half at square do ne ba sisi kaino ni siguma question ji multi-dimensional approach ni ana siguma ji noina revision hanba matamda kitang id section na ko id siguma ji kar hanjan ko approach id practice to siguma question ji ko direct id definition the best of the question oi bisa siguma ji tick tok salo ko it's important right yare adi makators question number 58 question number 59 question number 60 khallo sigi nina tawang ngamoy da yaw di sir daharo ko sir message antang thage okay fine so question number question number 57 tagre ka question number 58 59 60 sing amgadra question number 58 na hai kena 1 coolie takes 1 minute to raise a suitcase to a height of this but the second coolie takes 30 seconds to raise the same suitcase to the same height the power of two coolies are in the ratio so kai ratio da leidin hai ba amgadra si je ma'am sir ngamgani hai ba ka okay fine yare the question number 59
Habi oidara.
kai oidira ba si sa d oidira ba
D.
kai hamnu lakshmi sing tadre
D oidara 58.
have na question number 58 kiji 2:1 je oidira hairaba b hairaba
Oh, sir.
okay adudi hota di kangwe one coolie takes 1 minute to raise a suitcase to a height of 2 meter but the second coolie takes 30 seconds to raise the same suitcase to the same height so adudi mgh to the chapmanner ni aduga mgh by t ni amana 1 minute amana amana 60 second amana 30 second so makada denominator lakwen 30 by 60 1:2 tani d je taroidra ngaiko amazina 1 minute changba amazin 30 second changba ko 30 second ne hen na power ji kan do ni ga aduni d je taroidro habidi amaze first coolie is 1 minute changeba second coolie na 30 second khatang changeba adu power kanana hengeba second coolie du ne henro 1:2 daroi draba 2:1 ta duraba kumak tre 2 question number kai tare 58 ki di tai je yarba kumak
yarni sir.
yarnika okay fine. So question number 59, question number 60, yengo. A car of mass m starts from rest and accelerates so that the instantaneous power delivered to the car has a constant magnitude p naught. The instantaneous velocity of this car is proportional to have. So CGM like meaning I'm going to the hero, then 60 car. And question number 59, yung am gadra ma'am. Yadra. Saja kumnaro, sir kumnaro.
Sir, tawsira.
Okay, toes. Dollar again. Question number 59 is the lazy kano have a car of mass m starts from rest, so u equal to 0 pyramid masanaka. Rest they have accelerate so that the instantaneous power delivered to the car has a constant magnitude. The power p is equal to p naught, which is constant. C is constant or the instantaneous velocity of this car is proportional to have. So my velocity to put u and I have never. Okay, fine. Okay. Adu ibita argadi kuina kay kino toni ha matamda magi power hai kino power p naught have a z magi constant power do ni kaisa again yeah so p is equal to kino force into velocity auna m harga okay b minus u by t guys so hai lage ka ma force natra into my velocity is in a v so my le so u di 0 nika auna m v square by t tare duga c p naught adu the v square is equal to p naught t by m adu the it implies v square is directly p naught is constant ni massu dum constant ni the root t tare the directly proportional to t or v is directly proportional to t to the power half. So option B is the right answer. Gyan taita de.
Yes, sir.
Like so my leg t to the power half pa. Other than we know kasi am na malambe ko the t the square lakte na si the yeah right pa si so si tarat po. All right, fine. Atop di hero question number 60, 61 yengo. Sige chapter si loidi lo sila kadore ka. Hayeng adum lo sila sa gyan tana. Duga mathangi week ta di. Sarna hana luini ko. Next week ki di have the ay handa ki di kitang class ni mangi ni na noisy kitang tappe ko mathang week day tu na to ko din. Question number 60, 61 sasari yung say question number 16 is a body projected vertically from the earth reaches a height equal to earth's radius. Okay, no, Kingston called us radius. Hello, yes, Kingston. Sir, class story hero. Okay, no worries. Sir, class story buka yeah. Pare, tama. So a body projected vertically from the earth reaches a height equal to earth's radius before returning to the earth. So the power exerted by the gravitational force is greatest at the highest position of the body at the instant just before the body hits the earth. It remains constant all throughout at the instant just after the body is projected. Okay, no so CC no khalaga hero power gi formula palo aduga hero kain na kwai de kino to power is kam kanana kwai de greatest way power gi formula ji kaino energy by time natra. So energy is a constant for a body projected vertically from the earth reaches a height equal to Earth's radius before returning to the earth. So the power exerted by the gravitational force is greatest. Come kan the greatest for energy the constant ni aduragadi time do khaidagi minimum oiba matamda aduna at the instant just after the body is projected haibdu oirni option number D 0 oirni ko question number 60 gise moi kai oigeng si ko kitang controversial oibra question number 60 gise ko option number B oiba ko 60 gise B or ji kai gina moina 60 gise B at the instant just before the body hits the earth. Okay, kai you know. Let's think about
Sir, inversely proportional ba oidara?
let me think about it. Ka yeng si kay you know si I did D ne na lay ka so yeng si earth ki surface tagi ka si kanana no kinatok sa lay si da tik am ko sa lay kanana na si law to soy bu di waram so earth ki surface tagi ka kedoba body emerge projector eba duga magi radius to r height my height that is equal to r. A body from the original height equal to Earth's radius before returning to the Earth. The power exerted by the gravitational force is haveneva. So gravitational force ne exert the power haveneva. Adu the gravitational force na dum to doini, but power is equal to mgh to energy hata ka minus mgh by t. Mo si negative kong low lem na ko. Energy by time never. Total energy by time never ko. At the instant just before the body hits the earth, I ko. Why so? Total energy to the conserve for you ko. E to the conserve for you. The E is conserved. Time. Now, okay, fine. Now, power is equal to dot product of F and V never ko. Now, F and V z mengi kedoba F ka B ga si kedoba cos theta habidi kay na F B cos theta ne ba aduna cos theta z kedoba at the instant just before the body hits the earth na khwai de maximum moi sumai yeng tare kay no di aina lang ki matam da di ka powers force na negative force na downward ne ba velocity na upward ne ba gyan tai ta de tai ka velocity na upward and force na downward neba aduna cos 180 degree na power to negative 4 eba gyan ta right se tai ko aduan le neba aduga
Oh, sir.
aduga just before it hits the earth or gadi amuka f to downward v to downward aduna cos theta 0 degree 1 aduna dain torga p is equal to fb if theta is equal to 0 degree kind of sign ga torga kuina adurgadi option number P sinena sumaina khanbe yai ko but again sigum question ji kitang kaino toy phajaba wa le ko hadi sidi conceptual clarity the based of them gi terms ji kind term the twist over ko re magin yam kana kaino dan based of the knowledge to ko do you want anyway so gyan tabra yadra sige se
Yani, sir.
yarni ko okay fine bukya tare 913 ko again. So question number 61 jiding am gadra yang 61 is parang am gadra an engine pumps water through a hose pipe. Water passes through the pipe and lifts it with a velocity of 2 meters per second. The mass per unit length of water in the pipe is this. What is the power of the engine? Sisu noina kay kamay hot kani have the multi-dimensional approach ni noina kay dobang asay gi physical quantity sing gi dimension ji yang ga pansalaga hot ka doini ko. So noy ngamni ngamoy haro ngamni har gadi noy dum taw zero ngamoy har na sir to ke ko. Sasati hay na ro yang kuina matam logano.
Mamani, sir.
Ngamani ko. Thongambang ngamadra.
ꯑꯧ ꯁꯥꯔ ꯉꯝꯗꯧ ꯃꯥꯜꯂꯦ
Okay, fine. ꯑꯇꯩꯁꯨ ꯉꯝꯃꯅꯤꯀꯣ ꯆꯦꯠꯇ ꯑꯗꯨꯝ ꯈꯨꯝꯃꯣ ꯑꯗꯒꯤ ꯃꯊꯪꯗ ꯀꯩ ꯂꯩꯔꯦ question number 62 ꯁꯦꯀꯣ a particle of mass ꯁꯤꯗ ꯇꯤꯛ ꯑꯃ green tick ꯑꯃ ꯂꯩꯁꯤ ꯀꯅꯥꯅꯅꯣ ꯑꯝꯇ ꯂꯧꯊꯣꯛꯑꯣ ꯇꯤꯛ ꯍꯥꯞꯄꯩꯁꯦꯀꯣ Okay, fine. Question number 62 is paro aduga ngamgadre. A particle of mass m starting from rest undergoes uniform acceleration if the speed acquired in time t is v, the power delivered to the particle is I. This is am like so noina khanga de haro id ngamni ha de haro ngamoi ha haro saja haro 62 63 64 paro ka 62 63 64 je paro aduga noina karamba tawsige haro saja sator
ꯁꯥꯔ 63
63. Okay, fine. I got the water falls from a height of 60 meter at the rate of 15 kilogram per second to kaino sito uradane. Question anjale 0.90 to it. I togre ko si question tor togre ngasai chap mane. Kamang togre mane. Kai togre. Yung ko. Kai chakra sijira. Natte. Di togre nila. Ngai ko togre dane ba. CC 2020, 21 and 2008 hungry to see Sita Gravani. Then Chakshava Changi the Kangam Tongamba. Record session on you.
ꯍꯣꯏ ꯁꯥꯔ
Yeah. Next arrow. The 64, 65. Yadro 64, 65 say. Collision to Orzira. Pungi Pazare. Abdi collision tag. 64, 65 Jingam Hero. Sasa arrow. We don't have much time.
ꯁꯥꯔ ꯉꯝꯅꯤ ꯁꯤꯗꯤ
Money.
sir.
65 Chunga Maniko, Lakshmi.
Sir.
Okay, fine. I do the collision to ziko. Collision matem take. Yeah, tar. Collision tak thar. COLLI. Kari. COLLISION. Collision ka. Sir, double S man. Anyway, yeah, tars. All right, fine. So zik collision si kuina kaida we have matam da ko yamuna taro collision si da kamai to una da makal ji two types like ko collision si da makal ani lay kai no have da elastic collision have ma and amana kai inelastic collision have ma which is not elastic. Inelastic have the which is not elastic. Elastic haragana elastic kai ha. Now collision si da kaida we have the elastic oigera inelastic oigera collision da ko kaidoni have matam da munna yung ko sida sida momentum is conserved. Momentum is conserved ko natragana p is conserved harage sang yeroge ko swaino ni yeroge p is conserved au deke do ba amasidana kinetic energy is not conserved harage da you chal raha hai na kaise hoge ka is not conserved is conserved hoige dune ka. So 1 second. So dalen ka aduna sigi sida kaino hai matam da collision si makal ani lay ka elastic have ma inelastic have elastic tana p have di kaino p stands for momentum sida ina your p stands for momentum and okay K budi kinetic energy ni khang le ko K stands for kinetic energy ko yare now see na ka kitang can we chat like definition in chat le don't worry I'll explain what is collision I think stop set away ko munna taro ko collision is kind of collision is for example let's say put any khak mazi ke doni have the uniform motion the chatwini mazi uniform motion chatwini and ani thengai na duini adu the collision neba mazi resele me mana thome adu the collision neba mazi chatale me mana khra hena yang bai thome adu the collision neba sisu moinima kaidawi have a matam the constant velocity the ngata chatwini ko velocity kena bagi collide tawra kaduineba haibadi kaino have the particle anima kaidawi yade accelerate tawba yade particle anima acceleration to ko deba collision the first thing collision is the kaidawni ha matam there is absolutely no acceleration particle ani orga so anima accelerate tawde mazu individually accelerate tawde mazu accelerate tawde particle ahum thongai na gera mari thongai na gera tara thongai na gera infinite thongai na gera collision the acceleration ya sunya yade ko there is absolutely no acceleration ko gyan dai ko is aduna mazu magi on kedoba momentum mama carry to sa chain magi on velocity and my mass and velocity mazu my mass and velocity the aman aniji makta amana race layraga amana thomak pe ai natraga animak thomjana be ai or amana chatting ida amana tanara thom be ai ko so adumain le collision thom matam the straight line the rectilinear in sat pe ai or smain thom matam ka aga kedoba habidi plane do in sat kiba ko habidi angle amada sat kiba adumaina thomnar ji ai ko so there can be different types of collision but collision have the khwaidagi maru or sinoina ningzing the report si kaino have matam da acceleration ya sunya ya de collision ya requires adu ergadi noina adu di kaino have the according to the conservation of linear momentum ka acceleration later wise again external force yaw de collision the particles sing ja magi own by virtue of its momentum my own velocity da they happen to cross their path and then they collide without any acceleration, without any external force. But they only have the at the instant of collision, when you think they only have the body A and B the force P and equal and opposite force to B na so A the P ni aduna maram orga moini gi momentum dunga sileram budagi change lakani. Now la even momentum change external force na natte ko hoi system to the external force natte have one eva particle amamam to the yengagadi kai hagadiba individual particle the yeng bataraga the external force layeva individual particle have the particle A is sumain la particle B na thomam ni na or A na thome hager B na thome hager thom di thomam ni na magi momentum the change so kani my velocity change to kani ba ko adain to una Siju maga thom nauram ni na maju magi velocity change lakani magi momentum change lakani aduna particle A gi perspective ta yengba or B gi perspective ta gi yengba ko amamam tang oina yengadi external force layeba but whole system do the particle A B gi system do the net external force kayum layteba auna systems the net external force layteba targadi according to the conservation of linear momentum kedoba if the net external force is 0 the momentum is conserved aduna whether the collision is elastic or inelastic collision the momentum is always conserved momentum je adum conserve hoiniba regardless of whether it is elastic or inelastic momentum PEF je momentum je always conserve hoiba gyan ta hobra ta hodabra gyan ta hobra ta hodabra kumo
Tahoe, sir.
Lakshmi mathang ko meji kena
Sir, tahoe.
dagi cheta kumo sinthoi kumo cheta tai sir okay fine tabra tai ka okay so yare adurgadi ka adumain tawduna haidi again I am tanga hangi ko collision the quite important word is haziki particle collide tawnari ba particle sing do external force kem phang deba ana moi sing ji kedo we have the moi gi own momentum the chacha duni moi gi own uniform motion da have the constant velocity cha to ne kanam accelerate taw deba tawgadabu moi jina thomgai ne matam da di kedo ne have the particle amana amada external force pina amana amada force pini ba system gi mapan de force la oye ba ko moi amana amada force pina ni aduga moi gi kedoba momentum ji change tor kane ba do mapan dagi lakpa na teba a na b da piram b na su a da piram ne ba ko aduna adumaina tawgudeba so auna kedoni have the ziki particle mayam ziki systems the external force item nina momentum is always conserved regardless of whether it is kaidoba elastic collision or inelastic collision ko elastic or inelastic collision loina makta momentum adum conserve for sisima brain the option grow ko momentum is always conserved. And then what about kinetic energy? Kinetic energy they may be conserved, may not be conserved. Kinetic energy conserved the already adu gumba collision du kai kawi elastic collision however elastic collision has kinetic energy conserve for beduneba momentum conserve for body hydrosu yai kai no the momentum conserve for the collision ko dreva gyan da right momentum e conserve for extra elastic ka tokro inelastic ka tokro collision na teba do gyan da ko collision ho gya momentum conserve to oi gadam ne aduna moment akoina collision na makhala ni khaidui ado khaidui ji kai dano ha kinetic energy conserve oibra oidabra ha kinetic energy conserve organa kai kore kai kaudino myam sarna da ngang le thomba hero kinetic energy conserve
Elastic
organa
collision.
yes kai have Lakshmi kinetic energy conserve to ogadi kai kore ba
Elastic
collision
collision.
elastic collision very good elastic
Elastic collision.
yes elastic collision kinetic energy conserve hoiba inelastic collision hargana kinetic energy conserve hoidaba yare ko adu duma clear or lesi picture do adidi makha tarakpadi loina mak glide ni ko aduna collision gi the in any type of collision in any type of collision ko isa ji kitang infam mi phaire duna ne ibdu phaire je ko kai dongni have the pi total pi or pi is equal to pf have the or let's say m1 u1 plus m2 line m2 u2 plus m3 u3 plus dot 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 plus mn un is equal to m1 v1 plus m2 v2 plus m3 v3 plus dot 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 mn un. So this is important. Again, collisions. See, kaino have the momentum ni, momentum have the vector ni. Aduna kaina scalar type the treat the way at they all these are vectors. So my like then this is in any type of collision. C is the always true name. Yeah, reko. Number 2 is the kinetic energy is the if it is kaidova. If kinetic energy is conserved, then that collision is called elastic collision. If kinetic energy is not conserved, inelastic collision. Yeah, reko. Adu mind like then. So do you get a head-on collision and amatake? Do ga question solve to tabiani Yam queen low roy, head-on collision. Head-on collision, see kaino have the one-dimensional kai collision, elastic collision never ka. Na yung ko terms are very important. One-dimensional, rectilinear with a straight line, the one-dimensional. Kai so ba elastic so ba have the kinetic energy to conserve ba ka. That is known as head-on collision. So head-on collision da akoina let's say magi m1 lere u1 lere m2 lere u2 lere aduduna horen kaidoni have the b1 du kaino and v2 du kaino du puthok se ko head-on collision yare ko auna let's do it kaina kai khangi have the m1 u1 plus m2 u2 is equal to munengu ko class loidore is equal to m1 v1 plus m2 v2 yare ko adagi amana cc kaino because in every collision m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2 cc yare adagi kaidoba sigi one adu head-on collision ji kaiju oeba elastic su oeba ko elastic su oebanina aina half harga m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square sumana lai kadene ba sisi gyan tabra second equation ji gyan tabra mya tabro tadabro
ꯇꯥꯏ ꯁꯥꯔ ꯇꯥꯏꯌꯦ ꯁꯥꯔ
ꯇꯥꯏꯕꯀꯣ ꯑꯣꯀꯦ ꯐꯥꯏꯟ ꯑꯗꯨ ꯑꯣꯏꯕ ꯇꯥꯔꯒꯗꯤ ꯁꯔꯅ ꯀꯩꯅꯣꯝꯃ ꯇꯧꯔꯛꯀꯦ ꯑꯃꯨꯛꯀꯣ ꯃꯅꯦꯎ ꯍꯥꯐ ꯃꯌꯥꯝꯁꯦ ꯂꯣꯏ ꯀꯛꯈ꯭ꯔꯦꯕꯀꯣ ꯑꯗꯨꯒ ꯑꯩꯅꯅꯦ m1 ꯁꯦ ꯀꯣꯃꯟ ꯂꯧꯕ ꯇꯥꯔꯒꯗꯤ ꯀꯩ ꯂꯩꯅꯤ ꯍꯥꯏꯕꯗ u1 square minus v1 square is equal to m2 ꯁꯦ ꯑꯃꯨꯛ ꯀꯣꯃꯟ ꯂꯧꯔꯒꯗꯤ v2 square minus u2 v2 square minus u2 square ꯂꯩꯔꯅꯤꯕꯀꯣ ꯑꯗꯨ ꯑꯣꯏꯔꯒꯗꯤ ꯁꯤꯁꯤꯗ ꯑꯩꯅ ꯀꯩ ꯂꯩꯅꯤ ꯍꯥꯏꯕ ꯃꯇꯝꯗ m1 u1 ꯀꯣ ꯑꯗꯨꯗꯒꯤ ꯀꯩꯗꯧꯕ ꯑꯍꯥꯟꯕꯒꯤꯁꯤꯗ ꯑꯩꯅ ꯀꯩꯅꯣ ꯇꯧꯍꯧꯕꯅ ꯐꯗꯧ ꯃꯥꯜꯂꯦꯀꯣ ꯑꯩꯁꯨ ꯌꯦꯡꯁꯤꯀꯣ ꯏꯀ꯭ꯋꯦꯁꯟꯁꯦ ꯑꯩꯒꯤꯗꯤ ꯌꯥꯔꯤꯒꯩ ꯁꯝꯕ ꯄꯥꯝꯕꯗꯣꯏꯅꯤꯀꯣ ꯑꯩꯅ ꯀꯩꯒꯨꯝꯕ b1 ꯁꯦ ꯄꯨꯊꯣꯛꯄ ꯄꯥꯝꯕꯅꯤꯅꯀꯣ b1 ꯑꯣꯏꯅ ꯄꯨꯊꯣꯛꯁꯤꯔ b1 ꯌꯥꯔꯣꯏ ꯁꯦ ꯁꯤꯗ ꯌꯦꯡꯉꯨ u1 minus b1 is equal to m2 common lorogadi v2 minus u2 nebako. Let's say this is equation 1, let's say this is equation 2, and equation 1 and 2 implies sisima yen le sisigi equation 1 na equation 2 da yen ba matamda kai chatkre habada kai chatkre m1 chakre ama chakre du di u1 plus b1 is equal to u2 plus b2. So let's say this is equation 3. Yareko. Adirgidi aina putokadusi kaino, aina putokadusi b1 ga b2 ga pamaneba in terms of m1, m2, u1, u2 aitareko. Aduna si torage yo moneo. So adirgidi aina first equation se sigi sidako. Okay, yeah, let's say m1 u1 plus m2 u2 is equal to m1 v1 plus m2 harga b2 gi motaina kay habiya u1 plus b1 minus u2 habiya bako aduna adu ergadi aina kaidawni ha matamda haziki v1 kanguzi purage aduna m1 plus m2 harga b1 sile hore asomda loin pugrage audi m1 u1 pa m1 harga u1 minus b1 asomda pugi baini ko plus harga m2 harga u2 lene ko aduga sigi pot si kedoba m2 giti mem lene ko m2 minus u1 plus u2 so mine lere ko adu ergadi it implies v1 is equal to harga aina kai loba yai habada m1 by m1 plus m2 harga u1 minus kayino b1 ang ngai kayino no m1 okay sigi pot is for ebe ko sento ise m1 u1 dang oi gitini habidi kayino habida si b1 am le na ko aduga sigi similar na m1 u1 le na ko aduga si minus b1 0 m1 u1 dang oi gitini ko si se no my bad this is only m1 u1 haitare ko san thangdok thangin to ditang soirame so yare aduragadi not a big deal so m1 by m1 plus m2 u1 lere ko aduga asomda yelakaduni on a plus harga sigi si u2 ga twice 2u2 minus u1 kainom this for egis ko kainom for kai soina m1 b1 sigi tamjim lena ko aduga m2 b1 si tamjim ka si lehora matungda asomgi tamje m1 u1 lena m2 u2 leba lei adagi somgi sidi asigi m2 u1 di kachakraba m2 u1 minus oini buka yare aduga sisine m2 u2 sino plus oini buka so okay fine sisu yare kem kaide adudi u1 masen pun lo habne buka aduna ain to ji soire buka adi soire di yam kan soire nate adi sumain thamba yabre adudi u1 se kaidawni ha matamda m1 lena ko minus m2 by m1 plus m2 times u1 plus u2 with u2 plus u2 di 2 u2 haitare ka on a 2 2m2 है 2m2 by m1 plus m2 u2 है था सुमाइन तार आंसर से को यान ताब्रता ताब्रसी से मैं
Sir, tie.
ताए वो को जो
Hmm.
थियंग अमी यान ताए लाऊं अजिक ताए हाय ओवन फदु जाला का थिंग जिला मैंने को so anyway loidre ko silere sumain tawduna aina atopa kaidoba kaino yeng asi sigi sidagi similarly aina kaigumba sigi sidako kai chakre m1 u1 plus m2 u2 sigi equation jini ko plus haga plus not equal to ni so equal to haga m1 haga sigi v1 ze v1 की मपादा ने u2 plus v2 minus u1 है भी आएगा को u2 plus v2 minus u1 है भी आएगा को plus m2 v2 plus m2 v2 अदु ऐ बता रगदी ऐ न पामे जी v2 ने बा m1 v2 से संपूग्रो m1 v2 अदे plus m2 v2 को अदना मसी ऐ न याम समन लेन नोइन खनगद्रदि खंगदे ऐ न मु खिनदि नुमाइजबा को दि नोइ दम स्टेप अमा हापो m1 plus m2 v2 लेरे सोम साइड किसिनी को अदुगा नोइ निट थागद्रिनी न सिदि दुंगा मुथोइ को anyway so m1 ga sigi v2 ga cgm sakre adudi asongi sidi kaina m1 u1 amne na ko the u1 gi di minus siga di kedo ne have the 2 m1 by m1 plus m2 u1 ta ani ko aduga m2 u2 amne aduga u2 gi di m1 plus m2 da ni ka si asom sa sakre di m1 plus m2 nate asigi si m2 minus m1 la kani sorry m2 minus m1 by m1 plus m2 u2 la pa ko so sumain to duna koina ihe du di sigi si b2 ji asom na b2 dang iya ken bangida yare ko so sumain le gitu ni na sigi formula ji khangjalo si formula ji khangbe am live ni magi formula ji pattern nama dum chatpani bu ko kaiyum nang na v1 puthokningagadi m1 na chawbane ba m1 dagi m2 to subtract tawbane ba ai di chawbani di chawi chaw de khang de ko di formula si de m1 de m2 subtract tawga u1 gi mapa de m1 de m2 subtract tawba u2 da na 2m2 lakpa ka denominator chamana m1 plus m2 1 plus m2 ata v2 puthok ha gana v2 dagi ha di m2 de m1 subtract tawba na u2 ga pullani u1 da na 2m1 pullani ko so mind tawba de ko so this is the formula for final velocity v1 and v2 ko in head on collision aduga last topic oina kaidoba coefficient of restitution na ko adum tanga higher ngasi class losology question di hayeng holaji ko coefficient of restitution sijina muka kaino ay matamda magi symbol gadi kaino ju ko right ko sigi let's whatever symbol kai symbol bo janam to yengchira ya to sigi si kaino habida I'll just give it ka this is equal to relative velocity of kari relative velocity of separation SEPAR8 separation divided by relative velocity of approach so gyan tai ko ja sometimes ngauna bani have the kai coefficient of restitution is relative velocity of approach by relative velocity of separation oidura natragana separation by approach oidura na ngauna bani ba ko adu noi si su ngau dana ba sir noi da kaino ma hai ge ba sir na ja ja noi tar su ngau mun ngau ko si ni si da si ngau bu si kamaina phaduino haiba matam da sumaina khallo ba Lakshmi tabra thongba tabra
Sir, tie.
Tie, sir.
okay fine yung ko sigi sidda sir na haning is kaino ha matam da collision ji da ko relative velocity of approach is zero taba sunya ya roiba kai no di approach to na draga di kamai to ko lai to na drige amana race la ama thom gera moini sumai la thom gera can the relative velocity of approach ti dum zero ta ti sunya ya roiba ko but relative velocity of kedaba kai ha gena departure have kai sigida separation. So relative velocity of separation is zero tar ya pochi ani ji kedaba si thomgaina matamda ani ji punna merge to sakra ju ya ba ko aduna velocity of separation adi denominator zero ta ba is not defined in the no ko aduna relative velocity of separation si makada lakpya de relative velocity of separation adu mathakta le hello relative velocity of approach di makala ju ya gyan dai ko ya bra
Yes, sir.
dai ko thomam batabra
Oh, sir.
Like on relative velocity of separation can be zero. Relative velocity of approach is zero. It the collision tower because this is a bomb pokail the relative velocity of approach like but velocity of separation is lane. How do they coefficient of restitution put on a day? Coefficient of restitution put on a g kind of have the some 2, 3, 2 body system, 3 body system. Adulting do moisi approach toner matung thongaina matung the muk separate without relative velocity of separation by relative velocity of approach adu do yeng e ko so si simaga khangjal lo aduga makata abudi next class tawrsi ko ma'am yarba yare ko dudi ngasi class si sidalo shalati ko ma'am okay
Oh, sir.
thank you for the class ko no question ang bagay ko lo yes aduga hayeng may ngam do bagay ko laga work energy power solution logic ko fare tame ko tame okay good night
Sir.